Hello and welcome to Noel's Retro Lab. A few weeks ago we got this retro-futuristic Amstrad PPC portable working, and it's a pretty fun CGA MS-DOS machine, but it's pretty limited. So I have a lot of ideas on how to upgrade it. So today let's start with some of the low-hanging fruit and turn it into a much more usable machine. I want to start with some suggestions I got from people after last video. First of all, last time I wasn't able to get any video on the LCD when I had the CGA mode turned on. Some viewers pointed out that I probably had the wrong dip switches set incorrectly, so let's have a look at that. I had it like this, set to MDA, and I thought the CGA emulation would happen automatically, but apparently I need to set CGA both by flipping switch 2 and switch 5 to tell the computer I wanted to use the CGA mode. Okay, that's already more than I was getting other times, so that's a good sign. And yeah, there you go. With this configuration, it looks like we can kind of display CGA graphics on the LCD. Although now the missing columns of pixels are really noticeable. Yeah, I'm afraid I made it worse than it was when it had that black bar going through it. And also the ghosting is absolutely horrible. I'll experiment later to try to improve the missing columns, but I can't see using this LCD for anything. I'll probably just end up replacing it. Another suggestion from last video was that instead of just gluing the broken piece of the handle, everything would be stronger if I filled the handle piece with some kind of epoxy. That seems like really solid advice, so I'll do just that. I'll mix the two compounds and try to fill as much of that section as possible. And then same thing for the other side. Now I put the inner piece back and wait for the whole thing to dry out completely. And finally, another great suggestion was to use some kind of magnet or Velcro to hold back the door in place. Adrian from Adrian's Digital Basement had great results with some neodymium magnets, so I got some small ones to try it out. These kind of magnets are particularly strong for their size and weight, so they're perfect for these applications. I'll just super glue it to the case, figure out roughly the part of the lid that is in front of it, and then glue a washer on it. This dried right away, so let's try it. And yeah, that seems perfect. It holds in place, but it's still easy to open the door with one finger. Great! This video's sponsor is PCBWay. PCBWay makes high-quality printed circuit boards. You can just upload your Gerber file, look at it in the viewer, and reach out into the browser, and there you have your PCB. Okay, not exactly, but the turnaround time is really fast anyway. Highly recommended. With those little things out of the way, let's turn to the first upgrade. Having only a single floppy disk drive and no hard drive, it's kind of a pain. Loading things from floppy disks is not very reliable. Creating the floppy disks is, a little trickier sometimes. And really having to insert the MS-DOS disk every single time you reboot the computer is just plain annoying. So let's fix all of that by adding a Gotek. A Gotek is a floppy drive emulator. To a computer, it looks just like a floppy disk drive, but instead of reading disks, it reads disk images loaded onto a USB stick. They're fantastic little devices, and I've used them in all sorts of computers, from Amigas to Amstrad CPCs. To add the Gotek, we need to connect it just like we would a normal floppy disk drive. In this case, we need to remove a screw in the drive compartment and try to pry out that frame with the drives. It's really cramped in here, so it's easier said than done. Connecting the Gotek should be very simple. It's the same shape as a 3.5 floppy disk drive, so it goes right next to our existing floppy drive, and the connectors are the same. So really, we just need to plug in the data cable. You need to check that the red cable goes on pin 1, like that, and then the power cable. And of course I need to put a USB drive with a couple images. Okay, there we go. And we see some text in here, so at least it's being powered correctly and the firmware is working. So what we have here, by the way, is flash floppy. That's the firmware that I flashed on the Gotek ahead of time. So now we're having the computer boot up from the disk. So right now we have a blank image in here, and I also put the Planet X3 image. So just pressing the button switches between the different images. So now if I go to drive B, There we go. We get the full listing, as much as you can see in this screen, of all the contents in this disk image. So now we can execute it. And there you go. So the Gotek seems to be working great. One thing I like to do is to actually make this drive A, and for that I need to have a copy of this system disk on one of the images here. Now I could not find it on the internet, so I'm going to try to make it right now. So what I did is I made a blank image and put it on the USB drive. And now I'm going to try, because the Gotek is a full emulator, including writing to the disk, I'm going to try to make a disk copy from our original disk to the Gotek. So I'm going to try to use disk copy A to B and see if that works. While this is copying, I'll mention that the images I created on the Gotek had to be 720K, so double density, not high density. If you put a high density image, the Gotek supports it, but the computer doesn't understand that. So for this particular computer, we need to use double density images. And you can see here that it's copying. You see the track and the sectors that it's accessing. There you go. Supposedly that's copied. So let's go to B and check it out. And it looks like there's a bunch of files there, so that's good. The question is, did it copy the right boot up sectors and everything? So I'm going to install the Gotek as drive A and try to boot from it. Okay, so I think what I want to do is to put this one here and move this one over there. Mostly so it's a little easier to see the screen from the front of the computer. And then I believe we're going to have to change some of the driver jumpers. Sometimes the drive is selected by the cable. And I don't know, this computer, I think you may have to actually move this one. This one is set to S1, so maybe this needs to be S0 and change this to drive 2. So I'll have to experiment with the jumpers a little bit to make sure that this is recognized as drive A and this one is drive B. So let's put the jumper as S0, so I imagine this drive 0. Let's just see if this works before we even hook up the second drive. It helps if I actually put a USB drive in here. Okay, blank. And there you go. It booted up just fine from this one. Excellent. So let's hook up the real floppy disk drive as a B drive. That way I can always use physical disks with it, or it's also a super nice way to copy things back and forth in the USB drive in a real disk. Again, in this case, I believe I need to change this jumper to position 1, because that's going to be drive 1, 0, 1, so second drive. And let's try that. Okay, the Gotek and everything is back in place, and wow, that was a tight fit. Working there is not particularly pleasant. And we're going to turn it on right now to test it, but I just realized one thing. The little OLED screen that we have to know which image is there is right here to the side, so it's really not convenient at all. Now, this may not be a big deal if you're not changing disks very much, but if you are, it's kind of a pain. So I was thinking it could be a much nicer way to set up this mod is, what if we put the OLED screen and the next and previous buttons or a rotary control somewhere in here? Like maybe we can use this compartment here to set it up, or I don't know, something like that. I mean, this is a more advanced version. Let's see if this works first, but having that panel here would be awesome. Okay, let's try it. Excellent. It looks like it's loading from the Gotek disk. Notice that it's not any faster to load from a Gotek. It actually emulates the floppy disk drive, even to the point of taking just as long as a floppy disk drive would take. There we go. And let's see if Disk B is working. Okay, I don't have a disk, but I'm gonna pop one in right now. So yeah, that's great. So let's take the Gotek out for a spin and try a few games. Let's switch to CGA mode because I cannot stand that LCD. Unfortunately, I'm having some kind of weird shimmering effect that you'll probably see there, and I'm not sure if it's the video capture or the computer that is generating that, so it may be something I have to look into in the future, but for now, this is still way better than the LCD. So here we have finally Planet X3 in all its pink glory. And actually, this is one of the cool games that you can change the CGA palette, so that's always an interesting option. No CGA gaming session can be complete without some Prince of Persia. This was actually one of my favorites, and I loved the CGA version and all. Considering that this game was written originally in an Apple IIe, it's not surprising that it works really well in a computer like this, and even with CGA video. I also remember spending hours and hours playing Lakers versus Celtics. Oh wow, and this was not on purpose, but it looks like I actually removed the copy protection for this game because I used to sign my cracks as Dr. Watson. So great, otherwise I wouldn't have been able to play because I don't have the manual with me. What, a 3-pointer already? This is like foreshadowing of modern basketball. And let's try Commander Keen 4. This one works in CGA. So let's see how it plays in this computer. And oh, it looks like we can't play in this computer because we don't have enough RAM. This computer only has 512 kilobytes of RAM. That's why it's PPC512. So if we want to play Commander Keen and do other things, we need to add more RAM than that. I tried to confirm the total memory by running the mem command, but this is DOS 3.3 and mem doesn't exist yet. So I had to use check disk, which seems weird, but it gives you some information about the disk itself and also the total amount of memory you have in the system. And it shows 524,000 odd bytes. So that's consistent with the 512K that we know it has. There was another model released at the same time as the Amstrad PPC512, the Amstrad PPC640. This model had a darker case, it came already with a modem, and most importantly had 640K. Incidentally, I also read that the PPC640 had a bidirectional parallel port, whereas the 512 had a unidirectional port. I have some plans in the future that we're going to use the parallel port, so I don't know if that's going to matter or not. That's something to watch out for. In any case, I believe the boards used in the 640 and the 512 are exactly the same, so we should be able to upgrade ours to have the same amount of memory as the PPC640. As we saw earlier, the Amstrad PPC mainboard is split in two different boards. This is clearly due to space restrictions and needing to fit all that logic in a small space in the laptop. It makes it extra challenging to work on them, but otherwise it's no different than a single board. Let's start with the CPU. Where is it? It turns out the CPU is all the way there in the upper left corner. Even the location, it's a bit odd for the CPU. You'd imagine it would be much more centralized. The CPU itself is manufactured by Sony, but really is a licensed NEC V30. The V30 was an 8086 pin-compatible CPU running at 8 MHz. It was a full 16-bit CPU, not 8-bit CPU like I said a couple of videos ago, with a 16-bit data bus. It had a few extra instructions in addition to the 8086 ones, but I doubt they were used very much. Interestingly, the execution times of the 8086 instructions were slightly different than the original Intel 8086. I wonder if that was significant enough to affect some games. Next to it, in that empty slot, goes an optional 8087 floating point coprocessor. I remember from my early DOS days that for software that did a lot of floating point operations, like maybe interactive 3D graphics, whatever you had back then, having a version of the software that supported the coprocessor usually resulted in a big speed up. So I might look into adding one. Next, we have 16 kilobytes of RAM in two different chips. Since this is a full 16-bit bus, one of them holds 8 kilobytes of the even addresses, and the other one the remaining 8 kilobytes. Additionally, there's also another 8 kilobytes of RAM on the other board with all the characters. And we're finally getting to the RAM. There you can see two groups of 8 chips. The chips are labeled 41256. Whenever you see DRAM numbers, you can usually make sense of what they are. The 4, I don't really know. They all tend to start with 4. There's probably a reason for it. So we'll start with the next number. That's a 1, and that means it's a 1-bit wide, meaning that each chip will read or write 1 bit at a time. The remaining numbers are the amount of kilobits in each chip. So with a group of 8 of those, we have a full byte, because we had 8 bits, so now we have a full byte, times 256K. And with both groups, we come up to a total of 512K. If you look closely, you'll see there are 2 more 41256 DRAM integrated circuits. Those are used to check for RAM errors and contain the parity of each byte. Since we have 2 ICs, that's 512K bits, which is exactly 1 bit for every byte of RAM. So that matches our calculations exactly. See those empty slots? That's where the extra 128K of RAM goes to bring this machine up to a total of 640K. Without even looking at the datasheet, let's do some reverse engineering and figure out what kind of chips we're going to need. Let's see, we have 4 chips and we need to add a total of 128K of RAM. The chips are small enough that they can be 8 bits wide, so they either have to be 2 bits or 4 bits. They can't be 1 bit because we don't have 8 chips. I'm not familiar with any DRAM chips with just 2 bits, so we're going to have to go with 4 bits wide. In that case, 2 of these chips will need to provide 64 kilobytes for a total of 128 kilobytes. So each chip needs to have 64 kilobits. Following the convention we talked about earlier, the DRAM chips will have to be 4, because all DRAM chips of this type start with 4, 4 because they're 4 bits wide, 64 because they have 64 bits, so 4464, and that's exactly it. Sometimes you'll see it as 41464, and I don't really know what that 1 stands for. If somebody knows, let me know, because it's just mostly confusing. That 128K of RAM also needs parity check-in, so we need 128K bits spread on 2 different ICs. So that means we need 2 4, 1 bit wide, 64 bits, so 4164 DRAM. That happens to be a really common DRAM you'll find in a lot of 8-bit computers like Commodore 64, ZX Spectrum, Amstrad CPC, and many more. I won't get into any more details with the rest of the chips. I see there are a lot of custom gate arrays for different things, so maybe we'll talk about some of them when we dive deeper for some of the future projects I have planned. For now, let's go ahead and upgrade that RAM. As usual, I'm going to socket this, so the first thing I'll do is I'll remove the solder in each of the holes. I don't know why they're filled in. I guess it's just the automatic machine. Since these are soldered with a machine, just dipping it pretty much into solder. That's why they get filled in like that. So I'll remove those, put sockets, and we'll fill it up with memory. And yeah, I'm going to try to not remove the cables and work this way, just because the cables, it would involve opening up the drives again and unplugging everything, and I don't think I need to, because I can just flip it and work this way. I just removed all the flux as usual. I had the camera off when I did that. And now it's time to put the RAM chips in. And of course, we also need to swap the jumper to put it in 640K mode. Like that. So let's go ahead and test it. And oh, right from the boot screen, it says 640K. That's probably just the jumper position, I imagine. I don't think it's had time to really detect how much memory it has. And let's run check disk again. And yeah, 640K detected, so that's great. It looks like it worked first try. So let's launch Commander Keen 4 again. This time I noticed that it says 649K available for the game, so that's definitely more than before. And yeah, the game launches no problem this time. Yeah, so this memory upgrade worked first try, and really it was very easy. In one of the comments from last video, I was told that apparently the Spanish Amstrad PPC ROMs are not publicly available on the internet, and they were asking me if I could dump them. So since I have the computer open right now and they're socketed, let's go ahead and do that. As we saw earlier, there's a total of 3 ROMs. So we'll pull them all out. And yes, before anybody comments, I am wearing an ESD wrist strap. And now I'll go over to the laptop with the EEPROM programmer. They're each 8K ROMs, so I'll select some generic 8K ROM like 27C64. Disable all the pin detect and ID detects, and go ahead and read it. And yeah, it looks like it read it just fine. You can even see the copyright message at the very top. And I'll save it and do the same thing for the other 2. So 24 hours later, and this looks pretty solid. And actually, it definitely has more heft to it. I didn't put a lot of cement epoxy thing, but you could definitely tell. So this should be a lot more solid. The only drawback is that this piece doesn't come out anymore, but I don't expect to need it. So great, let's put it back in place. So there it is, very sturdy handle now, and they're showing off the Gotek as well. Too bad that it doesn't match this sort of darker beige more closely. It's just a gray, but still, it's certainly much better than the black one, which was the other option. But it could be fun to maybe spray paint it at some point. That would be very easy to match something this more closely. But no, overall, I think it looks great like this. And that's as far as we're going to get today. It's already much more usable than it was at the beginning, but there's a lot more we can do with it, like replace the LCD, add a hard drive, and try different expansions. So we'll get to all of those in a future episode. Anyway, if you enjoyed this episode, please give it a thumbs up and subscribe to the channel. Until next video, see you then. If you enjoyed this video, please consider supporting Noel's Retro Lab on Patreon or joining the membership on YouTube. Not only is that the best way to support this channel and allow me to continue making more videos, but you also get some extra perks like early access, ad-free videos, and more. Thank you again to all the supporters. See you next time.